Hello and welcome to part 6 of Dev Maths and Stats course lecture 2, where we move on to the products rule. So this rule says that if y is the product of two different functions, u and v, so y is equal to uv, if u and v are functions of x, then dy by dx is equal to du by dx, so differentiate u times v plus u times dv by dx. In other words, these two functions u and v, they take turns. First is the turn of u to be differentiated, and v has to wait, and then is the turn of v to be differentiated while u is not changed. So, as always, some examples are usually helpful. So you have a situation like this where y is equal to 3x to the power 4 times e to the power x. Now here you have two things, so you can differentiate this and you can differentiate this. So now we need a way of differentiating this times this. So if we see this as y is equal to u times v, if we see that part as u and this part as v, the rule tells us that to differentiate it, it's going to be, first of all, u differentiate. So differentiate this, so you have 12x to the power 3. That's du by dx, and v is left unchanged. And then we leave u unchanged, yeah, and we differentiate v, e to the power x, gives you e to the power x again, because this is the same when you differentiate it. So that's the final answer. So that's fine, but you can just tidy this up by factorising like that, but this is the same as this, made neater. So if you've completely understood that, you don't need any more practice, please just go on to the next video, but I recommend you at least try these yourself. If you can try them yourself, pause between each one of these, and if you want, I will then show the solution. If it's too easy for you, go fast forward, but I'll go through the solution of each of these by hand. So here's the first one. So here we're dealing with y is equal to x to the power 6 times log of x. Okay. Now, what I would do is I would visualize this as being y is equal to uv, where u, there's no need to write this out every time, y is equal to uv. So I'd visualize u as being equal to x to the power 6 and v is equal to log x. So these are the two functions. So this times this gives you y. So what you need to do is to differentiate each part separately. So I could write du by dx, but because they are both functions of x, we are only differentiating with respect to x. I will try to save some space and I will just write using this notation. So this means du by dx. So that means differentiate. So it's 5, oh, no it's not, it's 6x to the power 5. 6x to the power 5 and dv by dx, or v dashed, is equal to 1 over x. So that's differentiated that. Now we can start applying the rule, which is that, and here I'm going to write it out sort of in full, just at least the first time I do it. And I write it out using the dashes as well, just to make it slightly more concise. So the rule is that y dashed is equal to, you need to do u dashed times v plus u times v dashed. So first we differentiate this one, leave this alone, and then the opposite. So just to bring these things together now. So for over here we got 6x to the power 5, and from here we have log x. So that's this one differentiated times this one left alone. We add on this one now left alone times this one differentiated. Now I'll switch back to the same colour now for all of these. Just try and this is finished, now we can just simplify. So it's 6x to the power 5 log x plus x to the power 6 over x is x to the power 5. Okay, you could factorise out the x to the power 5 if you want this. X to the power 5 in brackets 6 log x plus 1. So that's the answer in label form, actually it's similar. Okay, next example. I'll copy this across. Please make sure that you are pausing and trying these for yourself each time. Don't only wait for me. I think this time, to save time, I won't do the colour coding in future. Just do it on the first one. So here we have y is equal to 4b e to the b. Incorrect, 4b to the power 8. 4b to the power 8 e to the power b. Okay, that's more interesting. So here we have a situation where u is equal to 4b to the power 8. That's my u. And then v is equal to e to the power b. So I just have to differentiate both. So differentiate this one, it's 32b to the power 7. Differentiate this one, it's e to the power b. Easy. And then put together what we want, which is this one differentiated. It's got to be, I'll write out the rule one more time. It's this one differentiated times this left alone plus this one left alone times this one differentiated. So that's this times this. So 32 b to the power 7 e to the power b plus then this one left alone, this one differentiated, 4b to the power 8 times e to the power b. Okay, and again you could take some common factors out of that. 4b to the power 7 brackets 16b bracket 16 e to the power and e to the b as well. So you could simplify it slightly, taking the 4 out of there. You could take the b to the power 7 out, take the e to the power b out. We're left with 8 plus b. Okay, let's see if we're in the right. Oh, no, Maple didn't simplify. Okay, so we've got better answer than Maple. Okay, as always, I'll carry on with this. On to the next one. Please feel free to skip if it's getting easy, but make sure you're trying them for yourself as well, if you're at all unsure. Try to clear this. Oops. So y is equal to, it's an unusual looking function. Don't often get a log and an exponent together, but it may happen. So e to the power m times log of m. So here u is e to the m, v is log of m. differentiate these. Using the simple rules. And then combine it back together to get y. This time I won't write it all out. It's this one times this one. This differentiated times this, plus this left alone times this differentiated. Oops. Okay, and then you can take out these then as a common factor. So that's that one. That's good. Next one. Y is equal to 7x to the power 2 times, and then brackets 4 minus 9x. 7x to the power 2 times brackets 4 minus 9x. Now, without using the products rule, you could expand the brackets first and then differentiate. But let's show you how you use the product rule for this. So obviously u is 7x here, 7x squared, sorry, and v is 4 minus 9x. Yeah, so we just differentiate these. V is -9. This is a classic situation where it's something very simple. I'll probably make a mistake with a negative number, so watch this. So y dashed is this times this, so 14x times 4 minus 9x. Here comes the first. Oops. Advantage of using not a real whiteboard, because I put this in a very inconvenient place. So that's this part times this part. And then we add on this one times this one. That should be a dash. That's differentiated. This times this differentiated. So here we have to remember the minus. So it's negative 63 x to the power x squared. And then you could leave like that, or you could expand it. It's not that important really. So if you expand it, you'd have 5856x minus x squared, 140x squared, 126x squared, minus 63 squared. So we've got 56x minus 199. Doesn't look at all familiar. I think I might have made a mistake here. Don't recognise that answer. Let's have a look and come back and see where the mistake was. Oh, it hasn't expanded it. Laziest thing you can get. Actually, looking at that sort of mistake is 189. Yeah, that's better. Okay, so that's differentiating that one with the product rule. Now onto the next of these. So this is y is equal to 5w to the power -3. Okay. E to the w. So I could write this as 5w to the -3, but it's more common to write like this, so power -3 times x with w. So u is equal to 5 over w cubed, and v is equal to the power w. Then you can differentiate these. U dashed, well, if you find this difficult, remember this is the same as 5w minus 3. So -3 times -5 is -15. And then -3 becomes -4. So this is w to the power 4. Okay. And then this differentiating this one, I still have got an equal sign that doesn't look right. Differentiating this one is v dashed is just e to the w. Then you combine that usual rule here. So y dashed is equal to this one times this one. So -15 e to the power w over w to the power 4. It's hard to draw on the screen sometimes, it's small. And that's minus. That's this times this, and then this one plus 5 w to the power -3. Let's use this version here. This one times e to the power w. So -15 over w to the 4 e to the power w, or plus 5 over w to the power 3 e to the w. The final answer. See if we're getting anything like that here. Okay, that's good. And the last one of all in this video, last example. It's y is equal to 6a, oh yes, and e to the a log of a. Now, I'm not going to do this all in color coding, but can you see what's going on here and how we're going to approach this? Because here we have this, which I can differentiate, times this, times this. So there are 3 things in the product rule. So what happens in this situation is that y is going to have to be given by, hopefully you can see how we're going to generalize this. If I call this u and this v and this w, these parts, then y dash is equal to, first of all, u gets its moment of glory and is differentiated, and v and w just wait. And then u has finished, so that waits there. V is now being differentiated, w is waiting, and then finally u and v have finished, and w at last has its turn to be differentiated. So that's how you generalize to 3 terms in the product, and you can expand that to 4 or 5 or more as you see fit. So let's just do this. So u then is equal to 6a, v is equal to e to the a, and w is equal to log a. So the derivatives are 6 e to the a, an old friend, the equals sign that's not really an equals sign. And w dash is 1 over a. So that's just a way of combining these together properly. So first I just differentiate this one, so it's 6 times these left alone, so e to the a log a, so it's this times this times this, plus, and then this one I leave alone, 6a times this one, e to the a, times this one again, so that's this one being differentiated, and then the last one is these remain unchanged, and this one we take the derivative. So the only real simplification here is that the last step you would just you can cancel this with this, so you have 6a. Okay, let's go back and see if that final answer is anything like it should be. And the answer is no. Okay, I was worried for a moment there. We have to put the command in. So if you have access to Maple, you can add in this command yourself. This won't quite work because we have to change this to a, that's the variable we're using. And this time, hopefully it'll, yes, that's better. That's what we got. Okay, so that's the product rule for when you have things multiplied together. And in the next video, we'll look at the quotient rule, which is for when you have a function divided by another function. But for now, thanks for watching.